Hello and welcome to Mr. Linford's math course. In this presentation, we're going to talk about very special types of equations that you might come across when in your algebra courses. We're going to talk in particular about things called conditional equations, contradictions, and identities. First, we should go ahead and actually define what each of these things represents. So I'm going to define a conditional equation as an equation. Okay, that seems pretty obvious. But we're going to say this is an equation with unique solutions, or solution or solutions plural. So this is a traditional equation that you might see. Things that you typically work with in class. Something like 2x plus 7 equals 5, whatever. This is an equation, and it has a solution. It has a unique solution, something specific to it. There are situations, and you'll come across these in higher level algebra courses, where equations can have multiple solutions, like 2 or 3 or 4. However, all of those have unique solutions. They're specific to that problem. They're specific to the rule that is determined by the equation. Let's talk about some other cases you might come across, some less obvious cases. The first one I want to talk about is a contradiction. This is a mathematical statement, sometimes referred to as a mathematical sentence, in which there is no solution. There is no solution. A false statement is produced. What do I mean by that? Let's take a minute and we'll see some examples in just a second. Let's let this kind of formulate a little bit for us. A math statement in which there is no solution. You have an equation that gives you no solution, and in fact it produces a false statement. I wonder what that could mean. Let's go ahead and identify what the identity means. In opposite of a contradiction, an identity is a mathematical statement, or a sentence, sometimes it's called, a mathematical statement in which there are infinitely many solutions. There are infinitely many solutions to an identity. A true statement. A true statement is produced. So a contradiction leads to a false statement, and identity leads to a true statement. We should know what a conditional equation is. It's just a standard equation you've worked with where you get a specific answer for the problem. But the contradiction and identity are a little weirder. Maybe it'd be helpful if we take a look at some examples. Here are 3 practice problems. What I want you to do is pause the video, take a minute to solve each of these problems, and I want you to see if you can identify which of these is a conditional equation, which of these is an identity, and which of these is a contradiction. And think about what tells you which one is which. What tells you that something's an identity? What tells you that something is a contradiction? So go ahead and give this a try. All right, well, hopefully you were able to work through and kind of discover what we're saying here when we mean a false or a true statement. Let's go ahead and let's start with, I'm going to start with the last problem. We'll work our way up to the top. 4x minus 3 equals 17. If we're going to solve this equation, we want to solve it for x. We want to get x by itself on one side. So I'm going to add 3 to both sides. We're going to get 4x equals 20. I'm going to divide 4 from both sides. And we're going to get x equals 5. This is a unique solution. We found a single unique solution. The only thing that works for this equation, the only value that works for this equation, I abbreviate that EQS, is 5. That's an important idea. That's why this, and I'll write this in red here, is a conditional equation. It's conditional, meaning your solution is conditional. It's based on what equation you have. There's a reason you got that solution. It works for this particular equation. Let's take a look at the other problems. Let's take a look at, let's go ahead and take a look at problem number 1. Why don't I solve this in a different color? Why don't I pick blue here? Okay, when you're solving an equation, or when you're simplifying a side to an equation, notice that we have a couple sets of parentheses here. We have a set of parentheses, and then we have a set of brackets, and we have a number on the outside. When we solve with multiple grouping symbols, multiple parentheses or brackets, again, parentheses and brackets are the same thing. You'll see parentheses, brackets, sometimes squiggly braces. They're all the same thing. It's just we have different symbols, so that way you don't see a bunch of parentheses. In computer science and in programming, you'll oftentimes just work with parentheses, and sometimes when you have like several sets of parentheses within each other, it gets very confusing. So that's why oftentimes when writing we use brackets instead, but they're basically the same thing. So I have an inner set of parentheses and an outer set of parentheses. Let's always get rid of the inner set of parentheses first. Always distribute to get rid of those inside parentheses. So we have 3 times, I'm still leaving the bracket, but on the inside, we have x minus 1. Notice that there's an imaginary 1 on the outside here, and it's negative because of the subtraction sign. So we're really distributing the negative 1 through. We're saying subtract x and subtract 1, and that's equal to negative 2. We can keep simplifying the inside. Maybe we'll say, you can go ahead and distribute if you want, but take a look here. X minus x, doesn't that just cancel out? And we're left with 3 times negative 1 equals negative 2. Or you could say negative 3 equals negative 2. Wait a minute, what? Negative 3 equals negative 2? Look at that, our x's canceled out. They disappeared. And we're left with a number equals that's not true. Negative 3 is not equal to negative 2. This is a contradiction. A contradiction. Because it produces a false statement. This is your false statement. This is not true. You have gotten rid of the variables. You've eliminated the variables, and you're left with a false statement. There is no solution for this. There is no value you can plug in for x to make these two sides of the equation equal to each other. So a contradiction really is a lie. You don't know it's a contradiction until you start simplifying it and you get it down to something like 1 equals 2, 0 equals 4, negative 3 equals negative 2, okay? You'll get it down to a false statement. At first, we weren't exactly sure what was going to happen, but when we started, we saw the variables canceled out, and we got this false statement. That means these two sides were never equal to begin with. They weren't. This was not a balanced scale. In fact, it was an imbalanced scale. One side was bigger than the other side. So, go ahead and try to plug numbers in for this. Try it. Plug numbers in for x. Plug in 0, 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Plug in fractions if you want. Anytime you plug a number in for x, you'll see that the left-hand side and the right-hand side do not equal each other. And in fact, you'll see that they always seem to cancel. Whatever you plug in for x will always cancel out with itself. So that's why this is a contradiction. You get a false statement, like negative 3 equaling negative 2. The last case, let's take a look here. Obviously, let's simplify the left hand and the right hand side. I can distribute this 5 through to get a 15 plus 5c plus 2. I can, let's see here, 2c and 3c, I can combine those to get 5c plus 17. I can combine 15 and 2, so I get 5c plus 17 equals 5c plus 17. I have the same thing on the left and the right hand side. Well, let's just keep going. Let's try to get the variables all on one side. So I'm going to subtract 5c from both sides. And they both cancel out. I'm left with 17 equals 17. This is a true statement. This is what we call an identity. An identity is where there are infinitely many solutions. A contradiction had no solution. An identity has infinitely many, meaning you can plug whatever you want in for the variable c here, and it will work. Go ahead, try it. Pick any number you want. Pick any ridiculous number. Pick something, pick a fraction. Pick a complicated number. Pick something like, negative 5,283,416. Plug it in. It's going to work. Part of the reason is because the variables you see, they'll just cancel themselves out. And what you're left with is the same value being equal to each other. This is an identity. Again, we don't know that by just looking at it. Looking at it, I assumed that there's going to be a solution. But as we worked through it, we saw what happened. We ended up with the variables canceled out, and we ended with a true statement. That's an identity. It has infinitely many solutions. Why do we talk about this? Well, we're going to see this pop up later on, this idea of no solutions or infinitely many solutions, and we'll have to think about what this means graphically. But just for the time being, we can be kind of comfortable with understanding that just because we're given something in an equation form doesn't mean it's always going to have a nice solution. Sometimes it's going to have infinitely many. We oftentimes call this trivial. You might hear me refer to that as a trivial case. And then we might also have something like a contradiction, something that just doesn't work. And in this case, like I said, we know from the get-go that the two sides weren't equal. They were imbalanced from the beginning. So that's the difference between a conditional equation, a contradiction, and an identity. If you have any questions, please let me know. My email is klinford, that's KLINFORD, @wccnet.edu. And until next time, take care.